So we're going to find x in the following right triangle. The right angle in the right triangle establishes that it's a right triangle. And the two sides that make up the right angle are always called legs. And the side opposite, or the other side, if you will, is the hypotenuse. And our Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. As long as the legs are on one side, hypotenuse on the other, you got it set up right. It doesn't matter which leg's which. I could put 12 squared plus 9 squared, or 9 squared plus 12 squared. Sometimes they give you the hypotenuse to make sure that you put them all in the right place, and then the algebra is going to work itself out whether you need to add the numbers or subtract the numbers to get what you're supposed to get. So, leg 12, so I'm going to put 12 squared, plus leg squared, I'm going to put 9 squared, equals hypotenuse, which is x squared. And since the variable x ended up all by itself on the right side, the numbers all by themselves on the left side, I'm going to square the numbers first, then add them together and follow the order of operations. So 12 squared is 144, 9 squared is 81, and if we add 144 and 81, we get 225. And when we know x squared equals 225, that means x equals the square root of 225. It can equal either the positive or negative square root. Keep that in mind. Anytime you have x squared equals number, plus or minus is possible. For the sake of a geometric problem, though, we typically look for the positive solution. So I'm going to just put positive here. The square root of 225. And then if that does evaluate, you should. Comes out to a nice pretty number, 15. So that's the general usage of the Pythagorean theorem. Just to throw an extra one at you in case they give you something like this in the homework. Suppose I have a right triangle over here. And let's say there's my right angle. Let's just say the hypotenuse is 7, and let's say this is 3, and this is x. Figure is not drawn to scale. All right, so notice the difference in the structure here. The two sides making the right angle are the legs. Leg 3, leg x, and hypotenuse 7. So in that scenario, if I do leg squared, that'll be x squared, plus leg squared, that'll be 3 squared, equals hypotenuse squared, that'll be 7 squared. Now, because the position of things, x is with a number and there's the other number, when I get this evaluated to x squared plus 9 equals 49, I got to move the 9 to the other side, so I end up subtracting the numbers to get x. So x squared equals 40, so x equals the square root of 40. Now I'm assuming, being in Algebra 1 last year, you guys did some breaking down of radicals, so I would expect you to be able to do that. So if we take a look at 40 and did a breakdown, that's 4 times 10, and then 4 is 2 times 2, and 10 is 2 times 5. If you get a pair of numbers in the factored form, doing a square root, you can take that pair of numbers out as a perfect square root. Leave the pair that didn't have pairs in. So 2 times 2 is 4, the square root of 4 is 2 taken out. 2 times 5 doesn't have square roots, so it stays in. So 2 times the square root of 10 is a better answer. Okay. Skill you, again, would have learned last year, but again, with the COVID shutdown, maybe you didn't, maybe you did, I don't know. So I would count this right now, but I want you to work on getting to the point where you're able to simplify those radicals as much as possible.